thank you everyone for joining this morning with me. It's indeed a great opportunity to share this emerging topic with all of you this morning. And we, as Net Reply, what we are doing in space, which is very interesting. So let me kickstart, and hopefully next over half an hour or so, we will be going through the overall landscape of 5G-NTN technology itself and how it is going to contribute in bridging the gap, the digital divide. So we Reply, founded in 1996 in Italy, and then we constantly working in the tech industry and reshaping it, especially in the area of the European technological sphere. Also in UK, we established ourselves as a quite formidable position with consulting, tech consulting, and system integration services, especially digital transformation services, with focus in cybersecurity, in data-intensive CI/CD pipelines, and design and implementation of newer products and R&D kind of services related to digital services and the tech industries. It's a quite wide spectrum of our services, our offerings. However, in UK, we have certain specialized companies within the system of Reply ecosystem of companies, and the entire Reply, it is quite a big footprint we have currently, not only confined within the European sphere. We do have a presence in New Zealand, in China, in India, Singapore, and we recently started our operations in North America and Brazil. In North America, especially in the networking domain, we started with name Net Reply US, and we're growing there as well. In terms of revenue and people, since our inception, we have been in a constant path of growth, and by the end of this year, we are envisaging a 2 billion euro company with working around 15,000 brilliant people around us. So it's a large company now with growing number of techies, brilliant people, attracting brilliant people from the market. So as I mentioned, in Reply, it's an ecosystem of companies, and there are specialized companies. We are Net Reply, who have expertise in cybersecurity and networking aspects of the digital market. And within Net Reply UK, we, apart from cybersecurity, our cybersecurity initiatives, we focuses in network services that includes, but not limited to, network architecture, network data, CI/CD pipeline, AI, ML-based services for cloud infrastructure for our customers, network virtualization, and network data visualization. And we do work in 5G and future network sphere, and that's the wing of business that I spearhead within Net Reply. So our focus through this PO is basically we work on the emerging technologies, especially in the 5G domain. In O-RAN sphere, we do develop XApp and RApps that adds intelligence to the radio access networks, which is in the open ecosystem of networking. We have quite dedicated resources for AI ML based software development, and also we are investing heavily in the XApp RApp domain to provide our customers with really innovative solutions that helps them to control their radio parameters and optimize the performance of their radio network. We do have O-RAN specific like dedicated team. We do go to ORAN Alliance's meetings, we do have dedicated teams in like who are planning expert in private mobile network. So that's the sphere who are also dealing with 5G NTN, which is today's topic that I'm going to cover for next few minutes. So before we talk about 5G NTN, the motivation of for today's talk for me was even bigger issue, that is digital divide. And this is a very, very famous picture that ITU came up with, and later UN recognized this picture, that the bottom line of this picture says that 1/3 of the world population, they don't have access to the internet. And this is not just a geographical problem. It has many layers of problems within it. And it is not, so the digital divide, that's the digital divide. However, the digital divide, this term was not new. Since very late 20th century, it was basically used to specify people, a difference between the people with cell phones and with those who didn't have cell phone at that point of time. But now with change of time, the gap now we are seeing in terms of technology accessibility is kind of only aggravated the divide. So today, the gap between the population who have access to internet technologies and who don't have access to internet technologies are basically coming under this umbrella term called digital divide. The reasons are not like anything specific, one reason. There are manifold reasons. The access to high-speed internet is difficult in many geographical areas for various reasons. Access to reliable devices are limited. And not only the technical aspects, but there are also some, we noticed also lack of motivation to use emerging technologies in day-to-day life. There are certain other difficulties, like for old people to get acclimatized with the newer ways to access technologies and get things done in a different way, like doing banking in a different way that they were used to. So these kind of factors have aggravated the situation, and it is not just a global South problem anymore. So recent statistics says that in global South, yes, it is understood that in Asia and in Africa, almost 60 and 40% people only come under the internet connectivity. However, more than half of the world population, they don't have access to high-speed broadband internet. And in global North, for example, the US students, 1 in 4 US students still don't have access to online schooling. And this problem was highlighted during the last pandemic. Even in UK, 5.9 million adults, they have never used internet technology. So in a nutshell, this is a problem, and it is not just a problem specific to global South. And if we look at in a different way, you can say there exists a global South within the global North. So we definitely need some ways to address this global scale problem, and because the impacts of such a divide is far-reaching. It's far-reaching. So it is not just an exclusion of digital inequality and digital inequalities. It basically, in turn, contributes to aggravate gender divide. It limits new generations to access and the frontier knowledge of the world. It has serious consequences on skill development programs in wide-scale areas, and also the socio-economic development is getting heavily impacted by the digital divide that currently we are facing, and it's real. It's real like any other social problem. It's not just a technical problem. It's a social problem, and the impact are not just static, like I have mentioned 4 or 5 problems here, but they are constantly changing. They're dynamic in nature. They're spatio-temporal with time. If not addressed immediately or in next 4 or 5 years, the digital divide will have even more far-reaching or problems that we need to stop. So now the question is how to blur the digital divide, and there are famously said things like the 3 A's of internet, the 3 A's of computer technologies, like the adequacy of the infrastructure, the affordability to access internet and technologies, and the access itself. So these 3 A's, the 3 A factors, needs to be addressed by the solution. Now, it is not just a digital literacy problem, as I mentioned earlier. It is not just a global coverage problem. There are geopolitics involved in it. For several reasons, local authorities turn off internet in certain rural areas to cut them off, and even due to remoteness of a locality, they always experience slow internet, or there are just a lack of enough computers or digital devices to access the internet. So as I said, the scale of the problem is huge. Now, the problem of accessing technology, the solution is yet another technology. Seems like, because we are networking engineers, we are digital domain experts in different ways, and we are special breed of kind of engineers who always take problems and try to solve it at scale. And seems like at this point, with the advent of 5G and other microelectronic advancement, it's the right time. Seems like that we address this problem of digital divide with yet another technology, and that's things like 5G-NTN. NTN stands here for non-terrestrial networks. As of now, we know connectivity, the mobile connectivity, as a terrestrial network connectivity, but now it's going to be a paradigm shift, and we are going to integrate non-terrestrial networks like satellites, like HAPs, with the 5G mobile networks and all. So that's being the focus of the rest of the talk today, how we can leverage on 5G NTN technology, which is and what are the benefits and challenges of this technology to implement on the ground, and how in turn it can help us to overcome the digital divide that we have been talking about. So if we look at the 5G or any other legacy mobile network architecture, it has been broadly like 3 parts are there. One is the RAN, radio access network, that is generally served by a tower or tower master antenna that is there and connected with a G node B. And then the last part is the core network. In 5G core network, it is also revolutionized from 4G and its legacy counterparts. But this is more or less how the terrestrial network have been working since GSM days, like RAN, radio access network, and the G node B, the UE, the G node B, and the core network. Now with the terrestrial bit, the NTN bit is basically introduction of the satellite links. Now, it's quite interesting at this point because it's not the first time that we are using satellite to facilitate the mobile networking. However, if you remember, in GSM days, we used to aggregate traffic and use satellite links in the transport network to communicate those aggregated traffic back to the core network or data center. However, the key difference here is we are integrating satellite links in the RAN segment. That's the catch. That's the paradigm shift that has been introduced by the recent development. So here, the aim is to get 5G or 6G directly from the space, directly from the satellite. If you even in a remote network, you are having a smartphone which is almost similar smartphone that we are using these days, can directly talk to the satellite. That's where the new aspect is introduced. So in this particular schematic figure that you can see on the slide right now is basically representation of a straightforward implementation of 5G NTN, where the satellite is basically used as a mirror, as a bent pipe that receives signal from the user equipment and beamed it back to the ground-based G node B through satellite link. And basically, it is nothing but mirroring the signal. It is catching the signal from UE and amplifying it and send it back to the terrestrial network. It is the simplest way to implement the RAN amplification in the terrestrial network through satellite. Now, this is the very first step, but it is not certainly not the end. We are not using any expensive computation on board on the payload of the satellite here, and the satellite can be GEO or LEO or MEO kind of orbit satellite with different consequences. So I'll be jumping in that in a bit. So basically, the whole idea of 5G NTN to introduce satellite within the RAN sphere of the network, so that the coverage footprint is bigger than and bigger and ubiquitous than the single or terrestrial network, and it has potential to solve the global scale coverage problem with a lot of with a higher number of satellites in the space. So integration in RAN part of the satellite is the key difference, as I mentioned, and it is basically, in other words, satellite communication, which is already 50 years old now, and more than 50 years old now. It has already having its own set of protocols. It has already having its own set of defined rules to communicate with the rest of the networks. However, the rules, so-called, the protocols, so-called the S2 family of the digital video broadcasting and the navigation standards like Galileo, they are all developed by satellite people, not by the terrestrial mobile people. But the terrestrial mobile people or the terrestrial network, they speak the language that is developed by 3GPP. For example, the GSM, the 2G, the 3G, 4G, and 5G, they are all like 3GPP standard, and it has this backward compatibility that you can see that if there exists a 3G network, still you can use your old cell phone to use or access that network. That's the brilliance of 3GPP protocol. Now, here, the important bit is now your satellite link is going to speak 3GPP language. And in other words, your cell phone, your mobile network is now going to speak satellite language. That's the conglomeration. That's the merging that is happening, and that's quite good. I mean, you are having now a merging of two different technologies, two different industries. The space industries and the mobile industries, they're merging, they're speaking the same language, which is developed by 3GPP now, and it has certainly the impacts, the consequences are widespread. So as I mentioned, the 5G and 2G, these are the 3G, 4G, these are the mobile generations of protocols that are developed by 3GPP, and NTN, the 5G NTN integration, or the satellite integration with the terrestrial network, they are also developed by 3GPP. So in a generic view, if you're introducing a LEO or GEO-based network node in a terrestrial network, try to integrate them, you basically have to have two basic links. One is the NRUU, the air interface link, through which the satellite is going to talk to the UE, and another one link that the basically the NG link that the G node B is going to talk to the core network, the MF. So these two key protocols with all its the different integrity and different security aspects, all developed by 3GPP. And for example, the ANR, the air interface was developed and it's basically developed by the TSG, the Technical Specification Group of RAN, Working Group 2, and the NG specification is developed by 3GPP TSG RAN Working Group 3. So now these protocols, which have been heavily used only by terrestrial networks so far, are now going to be used by satellite manufacturers and satellite links, SATCOM itself in general. So 3GPP release 17 has been the historic in that sense, because 3GPP release 17 was the first time in 3GPP history or in mobile communication development history where NTN has been integrated with 5G. That's why it is so important and it's historic in that sense. And if we look at the release 17 specifications, so you can see that the basic first step that we just mentioned, like the transparent payload, the paint pipe like mirroring of receiving signal from UV and transmit back to the Earth station is the first step, and that has been standardized and adopted in 3GPP specification. And it's not just LEO or GEO. You can also imply. It is also implied that HAPS or high altitude platforms can also be deployed for this purpose. Generally, the FDD, the kind of communication where you use basically two different frequency band to uplink and downlink signal and talk to satellite are used. So that's why the dual duplex of the frequency division duplexing is used under 7 gigahertz band. However, band is something that, or spectrum is something that 3GPP is not standardizing. It is ITU or local government, they take care of it. But 3GPP envisaging specification that FDD below 7 gigahertz is kind of standardized in release 17. So UEs with capabilities to talk to satellite can have those features and can talk to satellite directly. The key aims remain the same. The service ubiquity, the footprint should be at the global scale coverage of 5G directly from the space. So it will provide the continuity of the services from so basically handover from terrestrial network to the satellite network or NTN network. So this continuity from TN and NTN and so on is also defined. The scalability is also defined, taken care by the specifications. And AG RAN enhancement also required, and it will just the implementation is just the introduction in the release 17, but it will continue on 17, 18 and 19 as well. So seamless, so bottom line, the seamless service continuity between TN and NTN, and also integration of satellite in the RAN sphere. That's the key thing that is the paradigm shift in telecom network. And that's where 5G NTN is so important. And this is the right time to do 5G NTN because of the advancement of microelectronics and tremendous attention that we are getting from companies that we are partnering and all. So it has certainly a lot of benefits because you can readily get global scale 5G coverage directly from space. You can have NTN with the development of RedCap devices in next 2 years, can directly talk to satellite, although the IoT bit is still in its infancy, but we can assume and we can see that things are progressing in that direction. And also, if we leverage on the leverage on the LEO constellation, low latency connectivity and use cases will also be catered by the 5G NTN network architecture. That is quite significant because you can directly beam broadband connectivity to high-speed jets and maritime connectivities, and also enhance broadband to unconnected geographical areas, rural areas, and also significant difference in providing how we provide broadband connectivities and broadcast connectivities to rural areas will be basically going to be revolutionized from the space. So, however, nothing is free, and there is nothing called free lunch. We are having to have a hard time to implement those ideas, and there are certain challenges. For example, if we try to leverage on LEO terrestrial LEO orbits, the satellites are fast moving, so it gives high Doppler shift. It gives a very fast handover decision to make. These are the challenges that we need to overcome. And the movement between the UV and the nodes, the timing adjustment needs to be done that frequently and that perfectly. And these are quite time sensitive informations that needs to be computed on the fly. Uh, uh, and it is not just a computational problem. It is also coming up with newer, innovative algorithms that can help propagate through those uh, hurdles for us. So the payload microelectronics performance are still like under experiments how they are performing in different situations. So once those challenges are, we can handle. 5G NTN poses a great promise for the digital divide to be solved. So the NTN use cases, as we were talking about, it has immense possibilities, and we just mentioned quite a few here. Although there are certain use cases that has been identified by 3GPP and all, but for example, the global scale coverage, the maritime and airtime broadband service, direct to home connectivities using mobile connectivities, and use cases like emergency response and disaster management, and mobile network backhauling and IoT connectivity. So these are all, as you can see, can be then offload to satellite links, and this is a great opportunity for us to leverage and monetize those aspects. If you look at the NTN architecture, the current one is basically the transparent payload. We are not hoping to do a lot of computing on board at this point. If we look at the release 17, and you can basically transmit all the data from the UV to the back to the gateway or G node B through the satellite. It is just receiving and amplifying. However, with Advent and in next releases, you can have capacity to host bigger computers on the payload, where you can potentially uh, host the entire G-node B from the satellite. And that's where the link between satellite to gateway, that can be a different link, and that can be satellite radio, and you can the same satellite can still be talking to our smartphone with the 3GPP standard, the NREU. But on the other hand, on the other leg, it can use a different standard, and that's where the merging is happening. So if we look at the market right now, we can see there is the hot topic called direct to handhelds, and that is possible when you have a direct capacity to directly listen from the cell phone. And to do that, you need a bigger antenna and other microelectronic and antenna designing challenges to solve. And as currently we are also seeing like SpaceX, they have already mentioned that they're going to provide 5G operations from space with partnership with T-Mobile. And there are like other companies that are also doing in the same direction. And satellite operators are keen to reuse the mobile frequencies instead of the satellite frequencies to get into this space. And the current market trend says that there are certain fruitful partnerships we can see. For example, the ACS, the Luxembourg-based satellite company that has quite a good like history of serving people with new partnerships with BT and other, and also with OneWeb with different kind of mobile operators and so on. There are a lot of new players and new like partnerships that are emerging to handle cases like Lundy Islands cases that currently recently connected by OneWeb and BT. So these are the new trends. So this is the high time. It shows that it's the high time to do 5G NTN, and it has potentials to change the way things are done these days. And as far as the handheld devices market is concerned, the introduction of Snapdragon satellite, that's the new chipset that we are expecting. So once that hits the market, the entire spectrum of Android devices will also be able to talk to the satellites, and the market is already like estimated to be $16.1 billion by 2027. So so somehow I try to make the point that this is high time NTN 5G NTN can be done. And if we look at beyond 5G at this point and evolution to 6G, as I mentioned, Release 17 being the first historic stepping stone to integrate 5G with terrestrial network. So, and Release 18 and 19 will be working towards the same direction to more enhance and make the services more dependable, more reliable, more available. But if you look at the 6G evolution, which is the natural outcome of the 5G from Release 20 and onwards, when you'll be talking about the study items about different aspects of 6G, the NTN technology will be there from the day one. So 6G is always, so 6G will born with NTN facilities, whereas 5G is integrated first with NTN capabilities, and 6G will born with NTN capabilities, and we'll just optimize those aspects and leverage on those aspects to take even bigger challenges maybe in future. And these all can be done within the umbrella effort of 3GPP. So we Reply are currently also working in this field, and to advance the technology, we are using SDN kind of stuffs, and how can we use Geo Leo kind of. We are also working in test bed building. We are also trying to test if we introduce the more flexibility of the network in the satellite payloads. For example, if we place a bit of core network on the satellite, core network functions on the satellite payload, what will happen? How the network will behave? What kind of newer use cases it can handle? So we are doing this kind of challenging experiments in our test bed to see how with collaborations with our partners, and those experiments are really showing promises towards a more flexible and hierarchical network with Geo and Leo constellation as well as the terrestrial network. So recently, we are part of the space agencies. We have taken part of the space agencies project, it's 5G-TINA project, and you can check online. So we have been a constant contributor to the system integration process, the R&D project management with them. We provided with them with the basic MVN or the basic kind of transformation protocols, how we can place the different softwares and how the software function or the network functions can talk to each other in diverse conditions, like under heavy radio interference or fading, how these operations can still exist or we can still provide connectivities in challenging radio conditions. We also do that. We also done contributions in the test bed and the digital twin program that contributes finally with the findings will also help for the final or the further enhancement of the technology itself. You can have a look of the project, and that will be shortly hosting a public white paper in future. We'll be again contributing in that, and that will contain more detailed information how we make progress in the 5G NTN sphere. So with this, I would like to stop, and I will be happy to take some questions, and will be give you back, Jim, if you can moderate from here.